If I told you there's a place in our solar system where it snows metal, would you believe it? Sounds crazy, right? But this is actually happening on one of our closest neighbors, Venus. A planet so extreme, so unforgiving, that it defies everything we imagine about habitability. But how is this even possible? And could this alien world hold valuable resources for a future spacefaring civilization? Let's dive into the bizarre and hostile mysteries of Venus. Venus is often called Earth's evil twin, and it's easy to see why. It's similar in size, mass, and composition, and it even orbits within the Sun's habitable zone. But don't be fooled. Beneath these similarities lies a world that couldn't be more different. Venus is a scorching hellscape, with temperatures hot enough to melt lead, crushing atmospheric pressure, and clouds filled with toxic sulfuric acid. It's the most extreme planet in the solar system, a place where no human, or even most machines, could survive for long. While Earth is a thriving, water-rich planet, Venus stands as a cautionary tale of what happens when a planet's climate spirals out of control. Today, most people don't know much about Venus, even though it's actually closer to Earth than Mars. But it wasn't always this way. For a long time, Venus was one of the most exciting targets for space exploration. Its thick, mysterious cloud cover meant that scientists couldn't see its surface, sparking wild speculation. Could it have oceans, continents, or even life? But when NASA's Mariner flew by in the 1960s, those dreams were crushed. Venus wasn't another Earth. It was a scorching, unlivable hellscape. Still, the Soviet Union continued with its efforts to explore the planet. They launched a series of Venera probes, enduring countless failures until they finally succeeded to penetrate the dense atmosphere. Venera 7 became the first spacecraft to transmit data from the surface, and Venera 13 sent back the first color images of its barren, rocky terrain. These missions uncovered a planet of crushing atmospheric pressure, searing heat, and acid-filled skies, a place so inhospitable that interest in Venus quickly faded. Instead, all eyes turned to Mars, a world that seemed far more promising for exploration and, one day, even colonization. So, how did Venus become the scorching, unforgiving world we see today? Like the other terrestrial planets, Venus formed 4.6 billion years ago from the protoplanetary disk surrounding the young Sun. But in its early history, Venus may have looked very different. Some scientists believe it once had vast amounts of water, possibly even oceans, much like Earth. However, things took a drastic turn due to a runaway greenhouse effect, a catastrophic cycle where its thickening carbon dioxide atmosphere trapped more and more heat, eventually boiling away any liquid water that may have once existed. But the differences between Earth and Venus don't stop there. On Earth, plate tectonics constantly reshape the surface, creating continents, mountain ranges, and ocean basins. But Venus? It has no evidence of active plate tectonics. Instead, its landscape is dominated by volcanic activity, which remains the primary force shaping the planet's surface. And here's where things get even more interesting. Venus may still be volcanically active today. Recent studies suggest that ongoing eruptions are continually reshaping its surface. This could explain one of Venus's most unusual features, its surprisingly low number of impact craters. While its dense atmosphere burns up many smaller meteorites before they ever reach the ground, the real reason for the lack of craters is likely volcanic resurfacing. Frequent lava flows and eruptions are thought to erase older impact scars, constantly renewing the planet's landscape. and making Venus one of the most geologically active worlds in the solar system. With that in mind, what kinds of mineral resources could be found in such extreme environments? And why do scientists believe it snows metal on Venus? Let's take a closer look. One of the most likely mineral resources on Venus is linked to its widespread and ongoing volcanism. Similar to magmatic nickel sulfide deposits on Earth, Venus may harbor fertile intrusions, where molten rock cools and crystallizes, concentrating metals like nickel and iron. Additionally, some researchers speculate that Venus's active mantle dynamics could still be forming komatiite-related deposits, lava flows, which are rich in nickel, copper, and platinum group elements. However, since metals like iron and nickel are relatively abundant throughout the solar system and much easier to extract elsewhere, such as from near-Earth asteroids, it is highly unlikely that we will ever mine these deposits on Venus. And what about the so-called metal snow? Well, what scientists commonly refer to as metal snow is actually a layer of sulfide precipitates. Thanks to radar data from past missions, scientists have discovered highly reflective regions at the peaks of Venus's tallest mountains, some towering over 11 kilometers or 7 miles high. The best explanation for this phenomenon is that these areas are coated in lead and bismuth sulfide deposits. This process is thought to be driven by Venus's extreme temperature gradient. In the lowlands, where temperatures exceed 900 degrees Fahrenheit or 475 degrees Celsius, metals like lead and bismuth vaporize and enter the atmosphere as gases. As these gases rise to the cooler highlands, they condense and precipitate, forming a metallic layer over the mountain peaks, much like frost forming on Earth's highest summits. While the idea of mining Venus is fascinating, the feasibility of such an operation remains highly uncertain. The exact thickness and concentration of these metal-rich layers are unknown, and operating machinery on Venus, even in the relatively cooler highland regions, would be an extreme engineering challenge. One of the biggest obstacles to any mining operation on Venus is its deep and dense atmosphere, which exerts pressures up to 90 times greater than Earth's, enough to crush standard equipment within minutes. Then, there's the intense surface heat. Temperatures on Venus exceed 900 degrees Fahrenheit, 475 degrees Celsius, making it incredibly difficult to operate machinery or landers for extended periods. Any equipment sent to Venus would need advanced heat-resistant materials and cutting-edge cooling technology. However, even cooling is a challenge. The planet's thick atmosphere prevents efficient heat dissipation, meaning traditional cooling systems would likely fail or require a completely new approach. On top of that, Venus's toxic atmosphere, rich in sulfuric acid, would rapidly corrode most materials. Specialized alloys or protective coatings would be essential to prevent equipment from degrading too quickly. Another challenge is the lack of water. On Earth, mining and metal refining processes often rely on water. But on Venus, we would need to develop entirely new dry processing methods tailored to its extreme conditions. Despite all these challenges, there is still a case to be made for investigating these deposits further. Lead, unlike iron or nickel, is relatively scarce in the solar system. While Earth is enriched with lead-bearing mineral deposits, we currently have no evidence of significant lead sources elsewhere in our solar system. If alternative sources cannot be found, and if lead proves irreplaceable for certain critical applications, then one day humanity might have no choice but to turn to the snowy, metal-coated mountains of Venus. While mining Venus may remain a distant and unlikely possibility, the planet is still a fascinating scientific target. Its extreme environment, mysterious geology, and unusual metal snow deposits raise plenty of questions worth exploring. That's why NASA and other space agencies are planning new missions, such as DAVINCI Plus and VERITAS, to take a closer look. These missions will help us unravel Venus's history, study its atmosphere, and understand what makes it so drastically different from Earth. But what do you think? Will we ever mine the metal snow deposits of Venus? Or is it just too extreme? Let us know your thoughts in the comments below. And if you enjoyed this deep dive into space exploration, don't forget to subscribe for more exciting space content. Check out the links below to learn more about the future of space mining, and as always, keep looking up.